So in the last session, we talked about kubeconfig file and some basic commands, basic kubectl commands, right? Okay, so today we will start with Kubernetes pods. So this will be our first object in Kubernetes. So where we'll understand a lot of topics related to pods, containers, okay? Running some commands inside the containers, copying files into the containers. So how can we have multiple containers in a pod? Okay, multi-container patterns, the restart policy, pod lifecycle, commands and arguments. So there are multiple things that we have to cover in pods. So it will take a lot of time. Okay. So basically, what is a pod? So pod is, the very basic unit in Kubernetes. So this is the smallest unit that you can run inside a Kubernetes cluster. And pods are often ephemeral in nature, which means so they will be created and destroyed all the time. Okay. So what is the difference between a pod and a container? Okay. So basically you cannot run your application in the form of a container in Kubernetes cluster. You have to run it as a pod. Okay. So then what is the advantage that we get when we run a particular container as a pod? So why can't I directly run a container inside a Kubernetes cluster? Okay. So we will understand that as well. Okay, so I'm just taking this as a pod. Okay, so we call this as a pod. So inside this pod, you can have container. So I'm just considering only one container for now. Okay, so the container can be anything, like it can be Nginx, Jenkins, it can be anything, right? Right, guys?
Right.
Okay.
Yeah.
And a pod can have multiple containers. Okay. But wherever it is possible, you need to, basically make sure that only one container is running inside the pod. But it is not a restriction. You can always create other containers, within the pod. So it's not like that you can add extra container once a pod is created. You need to make sure that before pod is created, you decide the number of containers it should run. Okay. So what is that nature and all? Why I can't create another container or put another container in a pod? Once it is created, we'll see, we'll understand that. Okay. Yeah. So the first question is, so why I should not go for multiple containers in a pod? Okay, that's the first question. Okay. So we know that pods are ephemeral in nature. Okay. So which means they will be created and destroyed all the time. They are not permanent. So another thing is, you can scale up the pods. Okay. So let's say, I have an application stack that requires a front-end application and a database. Okay. Let's assume these two are running inside a single container. Okay. So I'm calling them as C1 and C2. So C1, I'll call it as a front-end application, okay, which is based on some front-end technology. And let's say C2 is MySQL. Okay. So of course, this also works. Okay. If a pod can have multiple containers, so in which I have put front-end and MySQL. Okay. But the problem with this here is, let's say I want to increase MySQL, the number of replicas or number of containers of MySQL. Okay. So I can't actually do that without impacting front end. Okay. So as I already said, pod is the smallest unit that you can create. Okay. If I have to increase MySQL, so what I have to do, I have to create another pod, and inside that pod, it will again have front end and MySQL. Okay. Because the same pod will be exactly replicated. Okay, so this is the replica 1 and this is replica 2. So again, I'll have front end and MySQL. So which means if I have to increase MySQL, front end should also be increased like this. Okay, clear?
Clear.
Okay, which means your pod will be scaled in such a way that the containers inside it will also be scaled. Okay, but I don't have requirement of increasing the number of replicas for front end, but still I'm forced to do it. Okay, but what if I separate them into different containers? Sorry, different pods. Like front end I'll run as a separate pod, and for the back end I'll again create another pod, and then I'll put my MySQL separately. So in this case, these are separate pods, so I can individually scale up or scale down. Okay, in case if I want to increase MySQL, so I'll simply increase the MySQL pods. Okay, so this is replica 1, this is replica 2. So in this case my front end is not impacted. Okay, this is the main reason uh, why you should not put main applications inside a single pod. Let's say if you have two main applications like front end, back end, and database, so always make sure that they run as separate pods. Don't try to put them as containers within a single pod. Okay, and also in the multi-container pattern, okay, where we can have multiple containers in a single pod, the other containers like C2, C3, okay, so those are not actually your application containers. Okay, so these are considered to be helper containers, okay, which do not add much value to your front end or the main application. So always in multi-container pattern, right, your first container, okay, or at least one container should be your main container that runs your main application. The other containers are just like your helper containers that will either help the main container or extend the functionality of the main container. Okay. So this is how your multi-container pattern should look like. It's not like every container runs a main application or some important application. Clear, guys?
Vikram, one question. Like you said that we cannot have these two front end and MySQL in one. Like we can have, but we can't separate it. Like
Hmm.
can't we produce MySQL pods individually,
Yeah, you
scaling,
can do that.
and those
But
pods will communicate with the pod having front end and MySQL.
yes, you can do that. That is an indirect way you can do that.
Okay.
Okay. But that implementation itself is wrong. But yeah, you can do that.
Okay.
Okay. Yeah. And one more thing. So once a pod is created, okay. So just like how a container is created, we get an IP address. Once a pod is created, we will also get an IP address, not for the container, it is for the pod because pod is the smallest unit. Okay. And of course, when we talk about container, we come across the concepts of Linux namespaces and C groups. It's the same concept that Kubernetes also uses. Of course, it's not any concept related to Kubernetes because it is responsibility of the container runtime to create these containers. So your container runtime, whatever you have used within the cluster, it uses the C groups and namespaces. Okay. And one more thing before proceeding further, whenever you're learning anything related to Kubernetes, always try to follow the documentation. Kubernetes.io is the official site. Go to the documentation and then here click on concepts. Okay. So here we are actually, talking about uh, workloads. So in the workloads, you will find uh, what are the workloads that you can run. Okay, so basically pod is one workload that you can run, but pod is not considered to be a permanent one. It is ephemeral in nature. Okay, a pod will be destroyed in case the node in which it is running fails. Okay, in that case, what Kubernetes can do is it can create another pod in another node, but uh, it won't work in case if you're running a pod as a pod. Okay. Only when you manage a pod with controller like deployment or stateful set or replica set, then only if a pod is destroyed due to some issue, another pod will be created in its place. Okay. But if you're running a pod as a single standalone unit, If the pod is destroyed, Kubernetes will never try to bring it up. Okay, that is one thing that you need to know. And when you're running, when you're going through this documentation, you'll find a lot of links, both for the concepts and for the tasks. Okay, I suggest you always implement these tasks that are listed in the Kubernetes documentation. Okay, you can also find all the tasks here. Okay, so as soon as you're done with a specific concept, go to these tasks and see whether you can implement any of this. Okay, so in the workloads, we are going to look at the pods. Okay, so pod, as I already said, it is the smallest deployable unit that you can create within a cluster. It can have multiple containers. Okay, yeah. So what are those containers? What are the patterns we have? We will see later. Okay, now this is pod definition. Pods and controller. This is how you. So let me come from beginning. Yeah. So pod can run a single container. This is the most common use case. And pod can also have multiple containers. Okay, so we will talk more about this. Okay, so when a pod runs multiple containers, right? So I'm talking about two containers here, C1 and C2. Okay, so I'll just say this is based on some Ubuntu. This is based on some Nginx, just for my reference. Okay, so whenever a pod is created, an IP address is assigned to it. Okay, so IP address is assigned to which? IP address is assigned to the containers or at the pod level? IP address is assigned at the pod level. Okay, then what will be the IP address of containers? So there is no concept like IP address to a container. It is always IP address of the pod. Okay. Then how can I target individual containers? Let's say I have another pod somewhere in the cluster. Okay, it is running a container. Okay, this C3 container wants to talk to this C2 container. Okay, so how will C3 talk to this C2? Or how will C3 talk to C1? Because so we are saying the IP address is for the pod. Okay, I can reach the pod, but how to reach a specific container within a pod? Okay, so we will talk about that. Okay, we'll talk about that as well. So for now, let's understand about multiple containers. Okay, see, whenever there is an application running inside any of the container, we know that there will be a port number. Okay, so let's say Nginx runs on 80. Okay, so Ubuntu is not actually running any application. Let's say Ubuntu has some application running on port 3000. Okay, so it is running, Nginx is running some application on port 80. Ubuntu is running some application on port 3000. Okay, so can these two talk to each other? Yes. Okay.
Yes.
Okay, they will talk to each other, but how will they talk to each other? Okay, how will C1 talk to C2? Is it through container name or container IP address?
Mm, I think uh, local host.
Okay, so both of them we don't use. Okay, first thing is there is no container IP address. Okay, so both cannot find each with the IP addresses, and also using names we won't be doing it. Okay, so what is the alternative is, see, so the pod is a single unit. Okay, so this pod behaves as a single unit, providing a common networking for all the containers within the pod. So which means it acts like a single VM. Okay, and these C1 and C2 are just like local to each other, which means I can simply use localhost. Okay, if C1 wants to talk to C2, okay, so C2 is listening on port 80. So C1, what it will do is it will simply reach C2 using localhost colon 80, because 80 is the port number on which C2 is listening. So what if C2 wants to talk to C1? Okay, C1 is listening on 3000 port, so it is localhost 3000. Okay, how this is possible? This is possible only because the pod will create a shared networking namespace. That's the reason, this entire space within the pod will behave as a single VM, providing a common networking for both the containers. Okay, clear, guys? Okay. Now, how can these external pods talk to individual containers like C1 or like C2? Okay. So here, this C3 cannot use localhost because the containers are in a different IP address. Okay. And again, there won't be any pod to pod communication or pod to container communication. Just for sake of understanding, I'm eliminating the middleman, that is a service for now. Okay. So we'll talk about the service. But if I have to talk to the C1 container that belongs to another pod, okay, so it is always the destination pod IP address colon the same port number like 3000. Okay, in this case, C3 can use this pod's IP address colon 3000. And in order to talk to C2, it can use the IP address of this pod colon 80 of the container. Clear, guys? Okay, but we directly don't use the IP addresses and all. So I'll talk about the much better way when we talk about services. Okay. And what about a space like storage? So can C1 and C2 uh, share a common storage as well? Okay, so by default it is no. Whatever is the content in C1, it is not visible to C2, and C2 can't see whatever is the file system or content in C1, or vice versa. They both can't see each other. But if they have to share some common storage, so can they share? Yes. Okay. So what I can do is I can temporarily create a space, create a volume, and then I can put it into a pod. Okay. And then have this volume mounted into both the containers. Then whatever C2 writes into this particular volume, C2 can see it because this volume is mounted to both C1 and C2. So this is how you can also have a shared storage. Okay, that shared storage can be temp storage, I mean temporary storage, or you can also persist that storage, I mean the data inside that storage. It can be both. Okay.
So, Vikram, one question here. Can you go
Yeah.
back to the screen writing pad? Yeah. So, the pod will not allow the C2 to open 300, 3000 port. Is that some kind of a management done there?
Which one? I didn't get the question.
C2 is, can C2 also open the 3000 port, right?
Yeah, it can. No, no, no. See, you can't do that
So, pod does some kind
because
of,
port, yeah, because already 3000 is open in C1. You can't open C2 in 3000 port. The mainly because you can't differentiate C1 and C2's processes.
right.
Okay.
So, some kind of a management done by the Kubernetes
Y-
or by the
Yeah, yeah, by Kubernetes. Okay.
Vikram, if we mount one volume to C1, the same volume can be mounted to C2 as well.
Yeah, correct. You can do that. So that is how they share the space.
Okay. And whether the C1 and C2 of the pod one runs in same worker node, or the C1 and C2 can also be distributed among the worker nodes.
No, no, that's why I said containers won't exist as standalone. Okay, so it is a pod.
Okay.
So always look at the pod level. So where a pod can run in any of the worker node. So within that pod, you have containers. You cannot separate the containers.
Okay.
Okay. You can't individually run them in various worker nodes. Okay. And before going,
Vikram, uh, Where this IP pod are assigned from each pod?
So where this pod and all? Yeah, tell me.
Yes,
No, I didn't get the question.
the IP assigned pod, like which from which CID are, like from node CID are or what is it?
So that we will see later. Okay. So basically when we installed container networking interface, okay, so by default it comes with a CIDR range, or else you can also provide a different CIDR range. Using that, a pod IP address will be decided.
Okay.
Okay. Yeah, so this is the definition of the pod, but I am more interested in. Okay, so pod updation and deletion. Yeah. So resource sharing and communication among containers within a pod. Okay. So you can go through this. It's the same thing that we discussed about localhost and all. Okay. And here, uh, as I already said, a pod can have multiple containers. In fact, you can also have privileged containers. So privileged containers are, are set using our different options within the pod definition file. Okay. So what are these privileged containers is they get, administrative capabilities. In case if a pod, containers in a pod wants to access some underlying machines, hardware, or the devices that are attached to it. So any kind of admin privileges, okay, we can also provide to the container through a concept known as security context. So which we will see later. Okay. And yeah, so if you go back to this section called pod update and placement. Okay. So what is pod update and replacement is, let's say you created a pod and now you want to make some changes to the existing pod and redeploy it. Okay. So can you make changes to all the fields? So within the pod definition file, no, you can't do that. Okay. Once a pod is created, okay, there is some data that is immutable, which means you cannot modify that data. So if you have to modify that data, you need to delete the existing pod, then you need to apply the new manifest file or the definition file. Okay. So for example, once a pod is created in a namespace, okay, if you want that pod to be created in another namespace, first you need to bring down that pod and then you need to recreate in the other namespace. Okay. It's not like that you change that file, change the namespace value in that file and reapply it again. So it won't take those changes. Okay. So whenever you see those sort of errors, always make sure that you delete the existing resource and recreate it with the new values. So that is about pod update and replacement. So the main intention is, so here not all pod, configurations are replaceable. Like you can't just replace them like that. Okay. And then pod also has a life cycle. Okay, so what is the life cycle? Basically, the various stages that pod should go through. So before it reaches its final running state. Okay, so where can you see this life cycle and all? Again, you will understand when we uh, create a pod and see the entire details of the pod. See, once we create a container, so we use this command called docker container inspect, right? Similarly, we will see more details of a pod once we create it. Okay. So life cycle of a pod. Okay. Life cycle of a pod means all the states that it attain. So during its creation. Okay. First one is pending state. So whenever you create a pod, like you gave a command, okay, to create a pod, and these are the various states. So first is the pending state. So what is pending state? So pending state means the pod definition is accepted by the Kubernetes API server, but it containers are not created yet. Okay. So during that state, it will be shown as pending. Okay. So let's say I created a container, a pod with 5 different containers. Okay. So initially the pod should be in pending state because all those containers should be started. Okay. So when containers start, basically their image will be pulled. Okay. So there will be a time involved there as well. So which means during that time interval, the pod will be shown as pending state. So once all the pods in the once all the containers in the pod started, you will see that the pod status is marked as running. Okay. So when I talk about pod as running, it doesn't mean that all the containers are running. Okay. If I have 5 containers in a pod, if one container starts and is in the running state, the entire pod status is also marked as running. It won't wait for all the containers to start. Okay. Then succeeded state. So what is succeeded? So succeeded in the state, let's say you have a pod with one container. Okay. And that container's job is to do a small process and then to exit. Okay. So if that container completes its process and exit with a positive exit code, that is with 0, then that particular pod status will be marked as succeeded. Okay. So in this case, that pod, will not be restarted. Okay, because I have set some policy, the failed pods will not be restarted. So in this case, the pod will be marked as succeeded because the containers process is completed. Okay, if the container process doesn't complete, okay, if it runs all the time, then you will see that the pod is still in the running state. The fourth one is failed state. So failed state means, if you have a single container or multiple container, if at least one of the container failed, okay, or exited with a negative exit code, okay, it is marked as a failed state. Okay, this usually happens, uh, uh, when a container is not provided with proper configurations. Okay, so then the application running inside the container would obviously fail. Okay, in that case, the entire pod will be marked as failed. Okay, then another life cycle of a pod is crash loop back off. Okay, so what is the meaning of crash loop back off is it is crashing in a loop, which means it is repeatedly crashing. Okay, it can be due to any issue. It can be issue with the controller, it can be issue with the pod. So due to which the pod is continuously starting failing, and again it is starting failing, and it is happening very frequently, like it is not even starting properly. So if that failure repeats, your pod is marked as crash loop back off. Okay, so what is this meaning of back off? I have a separate slide, I'll show you. Okay, unknown means for some reason if the state of the pod cannot be read. Okay, in this case the status will be shown as unknown. Okay, so this entire state, okay, the pod state can be seen in a separate section within the what do you say, a pod definition file. Okay, so we will see that later, but this is the life cycle of a pod. Okay, so it starts with pending. Yeah, just a second. It starts with pending and then it will go to the running. From running, it has again two choices. Okay, if the process completes, it is marked as succeeded. If process fails, it is marked as failed. Okay, or else if the state of pod is unknown, it will be marked as unknown. Okay, so not only that, you will also have life cycle of an individual container. Okay, so what is the life cycle of an individual container? See, we created a pod. So pod has a lot of containers. Okay, individually container will also have some stages or states, right? Okay, so what will be various states? Okay, so whenever you create a container, so obviously it has to pull that container image and then it has to run. And there are chances that it also gets terminated due to some issue. We already seen this in Docker sessions, right? A container can be waiting. Okay, so which means it is currently pulling the container image from the container registry. And then once it successfully pulls the image, it will basically run. Okay, so while running, if it encounters any issues with the application, it goes into terminated state. Okay, so the terminated state here for a container can be anything. So it can be a positive termination where the process inside the container exited with positive exit code, or it can exit with a negative exit code due to some issue. Okay, so but for both the reasons, the pod will be shown as a terminated. Okay, clear, guys?
Yeah.
Okay, so the life cycle can be both at the pod level and it will be at the container level as well. You can see the that state. So once you create a pod, okay. Now coming to the restart policy. So we are saying a pod is nothing but a container. Okay, a pod will have multiple containers. So what will happen to the pod if the container fails or if the container exits due to some issue? So should that container be restarted by the Kubernetes system? Okay, so it is decided by the restart policy. Okay, so the default restart policy is always, which means, so if the container exits due to some issue, that container will be restarted. Okay, so we are not talking about the pod here. So we are not talking about creating a new pod. So here the pod will be like that, but the container within it will be restarted. Okay, to see whether the application recovers. Okay, even though you use a restart policy as always, but if the container has some issue, it will keep on restarting in a loop. So this is what we call it as crash loop, because it is keeping on restarting. Okay, so will the container gets restarted immediately? Okay, no. So basically, kubelet in that worker node will make sure that the container is not restarted immediately. So first it will restart immediately. Then it for the second restart. Okay, let's say as soon as the container started, it failed. So kubelet will not start it immediately. It will wait for 10 seconds. Then it will try to restart. Okay. Again, if it is failing and going into that exited state, kubelet now will wait for 20 seconds, which is double of previous delay. Again, if it is restarting, it will again wait for the double of previous delay. So this will exponentially increase, and it is capped at 5 minutes. Okay. So after this 5 minutes, even after waiting for 5 minutes, if the container cannot be in the running state, this is what we call it as crash loop backoff. Okay, so where container will not be restarted any further, because kubelet understood that there is some issue and container can never be restarted and made to be in the running state. Okay. And what about the restart policy of never? Okay, never means if the container fails, your your kubelet will not try to restart it. Okay. So will this restart policy applies only to a single container within pod? No. So restart policy is common for all the containers. We have 100 containers in a pod. There will be only one restart policy. Either it is always or on failure or never. So always means it will always restart. Never means it won't restart. But what is on failure? On failure means only if the container exited with negative exit code. That means it failed. So let's say I have a container whose responsibility is to count down from 10 to 0. Okay. So if it has completed counting down from 10 to 0, so it is not a failure. Okay. The process got completed and the container got exited with a positive exit code. Then this is not a failure. But what if the container, started counting down from 10, but it stopped at 5 and then the container exited? Then this is not a positive exit code. It is a failure. So in this case, if you have restart policy set to on failure, those sort of containers will be restarted, which are failed. Okay. But if the container exited with positive exit code, those will not be restarted. Clear?
Vikram, so if the container has, if the pod has two containers, if only one container fails, so will the other container get affected, or will this?
No, only the affected container. I mean the exited container.
Okay, so the restart policy is like I cannot say that the pod get restarted. It's not the
Yeah,
pod.
it is for the
Okay.
containers. Yes. So how will I know? Like, can I know this configuration whether it applies to the containers or it applies to the pod? Yes. If you look at the pod definition file, you'll definitely understand uh, to which object this restart policy applies. Okay. But for now, just think that this restart policy is for the containers, not for the pods.
So
Okay.
should we mark that pod as a running or failed, Vikram? If a container has a if a pod has a two containers and one is failing,
Hmm.
So should we say that as a failed pod or a running pod?
It's a fail pod.
Okay.
Okay, so let's look at this pod definition file. Again, I'll come back to this definition later, like how to write and all. Okay. Uh, yeah, so the default restart policy is always, guys. Okay, someone asked. Now this is a pod definition file. Okay, so here I'm trying to create a pod that is based on the container image known as busybox. Okay, and here what I'm trying to do is I'm trying to count down from 10 to 1. Okay, and here what I did is I set the restart policy to always. Okay, so if you look at this pod definition file, so the container section is using this hyphen. So why it is using this hyphen? So what is the use of this hyphen in case of YAML? It is a array, right? Yes.
Yeah.
So array means it can have more than one element. Okay, like 1, 2, 3, 4, like that. Okay, or else you know, you use this kind of notation. Okay, so containers can be more than one. That's the reason why here each container definition, will be given as an array element. So if I have one more container, I can use one more such block. Okay, and if you look at the restart policy, this restart policy is not starting from here, like restart policy is always. So it is not within this container definition. Okay, it is at the containers level. Okay, right? Which means it is applicable for all the containers within this single pod. Okay, now the question here is, I'm using restart policy as always. And if you look at the process runs within this VisiBox container, it will exit. Okay, after counting down from 10 to 1, it will exit, which means the process gets completed. Okay, and also I set the restart policy as always. Okay, so what will happen in this case? See, the process completes here within the container after counting down from 0 to 10 to 1. So after this, the container exits. Okay, and since the restart policy is set as always, that container again restarts. Once the container restarts, the application restarts inside it. Then again, it will count from 10 to 1. Again, it will exit. Then again, it will restart. Correct? So this happens within a loop. So after some time, you'll see that the status of the container is marked as crash loop back off, because it
But
is
you said
continuous.
restart is only for non-zero exit codes. This is a zero code, right? When it is successfully counting 10 to 1.
Yeah, but it is restart policy as always. So I didn't say restart policy as on failure.
Okay. So only on failure is applicable for non-zero exit codes.
Yeah,
And always is always for the
always.
both for negative and positive exit code.
Yes.
Okay, got it.
Okay. So that's the reason why the status of the pod is marked as crash loop backup, because it is continuously, failing, and kubelet cannot do anything more than that. Okay. Yeah. So multi-container pod design. So there are a lot of patterns that we can follow while using multi-container pattern. Like whenever we try to put an extra container within the pod. Okay, there are patterns like init container pattern, okay, sidecar pattern, ambassador pattern, adapter pattern. So all of them look like they do the same thing, but they have a different purpose. We will see them later. We won't talk about that now. Okay. Now let's look at some commands used to create pods. So there are two ways using which you can create any object inside
Vikram,
Kubernetes cluster. Yeah.
uh, can we control the restart policy for individual content?
No, you can't. It is at the container. All containers will have the same. So that's the reason why we say that restart policy is at the uh, all containers level. When we talk about all containers, we'll say that it is at the pod level.
All right.
Okay. So there are two ways you can create an object in Kubernetes. One is imperative way and the other is declarative way. So imperative way means it is ad hoc way. So where we directly run a command to create a resource. Okay. Declarative way means we'll be using YAML files, okay, to create the objects. Okay. So if you know Ansible, imperative way is just like ad hoc way. Declarative way is just like writing a playbook. Okay. So imperative way should never be used in case if you're deploying something in production. The reason why it cannot be used is it is command based. Okay. You cannot remember all the configurations that you passed when you run that command, and also you cannot version control a single command. Okay. You have to rely on managing all these commands or maintaining all these commands inside a file and version controlling that file, but it is not a best practice. So whenever you're creating any object, make sure that an YAML file exists, the configuration exists. Okay. And using that configuration only, you deploy that object into the cluster. And since this is a file, okay, you can easily version control it. Okay. Always make sure that you go for declarative way rather than imperative way. But if it is for your dev test or it is for your learning activity, you can simply go for imperative way. Okay. So we'll talk about how to do that imperative way, and then we will come back to the declarative way later. Okay. I think I'll talk about this later. So this is a declarative way where we'll write the YAML file, but I'll come back to it later. Okay. So we already seen this man pages, how to get the information about the API resources, API versions in the previous video. Okay, if you want to know what all the API versions supported within the cluster, you can run kubectl API version. If you want to know more about the resources supported, you can do kubectl API resources. Okay, using that you get to know like what is the name of the pod, short name for the pod, whether it is namespace scoped or not, what is its API group. Okay, all these things you'll get it from the API resources. And for getting the man pages for individual objects, we already seen how to use kubectl explain command. Okay, so I'll also show you again one more time. Okay, so these are the basic things that we also covered. The basic kubectl commands like getting the nodes, fetching the cluster information. Okay, now let's talk about how to create pods in an imperative way. Okay, so let's start with seeing the help of kubectl. Okay, so we will be concentrating on this run command. Okay, so kubectl run, it will run a particular image on the cluster. Okay, so which means it will create a container, which means it is just like creating a pod. Okay, let's see kubectl run -h. So what is this kubectl run will do? It will create and run a particular image in a pod. Okay, okay, so this is the syntax. So there is a difference between the syntax that we follow for Kubernetes and syntax that you follow for your Docker. There is a very small difference. Okay, so the difference is whenever we try to create a container, right? So what is the command that we use? It is docker run, correct? And the name of the image. So the name of the container we will write like this, correct? And then finally we'll write the image name. Correct, guys?
Yes.
Yes.
Okay, but in case of Kubernetes, it is kubectl run. Okay, so we don't actually name a pod like this. Okay, you can give the name like this without using hyphen name. But for the image, you don't directly put it like this. You need to give hyphen image. This is the difference. Okay, so it is just like creating a pod with the name Nginx. That pod will run a single container that is based on what do you say, this Nginx latest image. Okay, clear, guys? Okay. Now let's say I want to expose a port at the container level. I can use hyphen port. Okay, I need to inject some environment variables. I can do it like this using hyphen env. Okay. And if you want to set the restart policy, okay, you can set it using hyphen restart like this. I can in fact override the default CMD and entry point that is also there. Okay, I'll show that later when we talk about commands and arguments. Okay. Yeah. So these are the various options that you can use. Okay. So for restart policy, for creating the temporary pods, like so whenever we want the container which is failed to be auto remote, we use hyphen rm, right? Like -i -t. Okay, it is just like your normal docker run command. Okay, clear, guys? And also there is one more flag that we usually use, that is dry run. Okay, so what will this dry run do is it won't actually create the resource, but it will see whether the resource definition or the command that you are using is correct or not. Okay, so let's try running a simple pod. So kubectl run nginx, that is the name of the pod. Okay, so you must be wondering what will be the name of the container in this case. Okay, so whenever you're running imperative commands, Kubernetes will make sure that some names are pre-populated. Okay, so we will see that as well. So I can run like this. This image is nginx latest. Okay, so the pod name is nginx and it runs this nginx latest as the container image. Okay, if I enter, the pod will be created, but I can also use dry run equal to client. Okay, I'm trying to see the syntax and all. Okay, so it says a pod by the name nginx. Okay, so in Kubernetes, the resources will be shown like this: the type of the resource / the name of the resource. Okay, so it says created, but it is dry run, which means the pod is not actually created. Okay, clear, guys? So one important thing that we need to know here is, okay, so this is an imperative command. Okay, I can also create a pod using the pod definition file or the manifest file. So how that manifest file looks like, um, just a second, it's loading. Okay, so this is the definition of a pod. Okay, so where this pod by the name nginx is running this container image called nginx 1.14.2, and this is the port that is exposed, that is 80. Okay, so I can also, so this is your declarative way of creating a pod, right? So I can also do this using an imperative command by doing kubectl run. So the name of the pod is nginx. Okay, so nginx hyphen image equal to whatever image that I have, that is nginx colon 1.1.14.2, and port I can do hyphen port, I can set it to 80. So both are same, right?
Yeah.
Okay, I can do that. But the thing is, this is based on a file so that I can version control it. But this is a command which is very hard to remember and version control. Okay, so using an imperative command, can I get this manifest file? Can I generate this manifest file? Yes, I can do it. So this is what I'm going to show. Okay, so whenever you're trying to dry run, okay, it won't create an object. Okay, now I will output this entire command in the form of an YAML. Okay, if you see, I got the pod manifest file using an imperative command. So this is the quick way of creating this pod manifest file using the imperative commands. So what I'll do, I'll simply redirect it to a file called pod.yaml. Always remember dry run client is required, and then only you will be able to output in the YAML format. Okay, then I can have this what do you say, this file. Okay, so here some of the resources are auto generated, and these are all not required for you. Okay, so for example, creation timestamp is not required. It's not a mandatory value. Labels is not mandatory, but it is good to have. Okay, the resources that you set to a container, resource means how many CPUs or the memory required for that container. Okay, I can also eliminate this. DNS policy also, it's not required. Restart policy, if you want, it is you can set it to always, but that's the default value. Even if you don't mention, it is fine. So this status field will be automatically injected, okay, by your Kubernetes once it is created. See here, I got the pod manifest file. Clear? Got it, guys?
Yeah, understood.
Okay. So using this imperative command, I can actually create.
Can we use JSON and all as well?
Yeah,
And can we use JSON to create as well files?
I never tried it. So this is the JSON. Okay, of course I named it as YAML. So this is the JSON representation of it. You're talking about whether I can create.
Yeah, from JSON.yaml. I mean,
Okay, we'll see it. I think it can be done. I never tried. Yeah, you can create it.
okay.
So this apply command is used to apply from a file. Delete is used to delete that particular definition mentioned in that file. Okay, again, I'll come back to this later.
Vikram, what is this client after dry run?
So client, basically, you can run this validation at the API server level or at the client level. Client level means only kubectl will validate your request. Okay, if it is not there, means that request would actually go to the API server, and API server would validate this whether you can create this pod or not. Okay, so it is an
All right.
unnecessary overloading the server to make the validation for you. That's the reason why we will be validating only at the client level, like kubectl level.
All right. So does it mean, like, let's say key a pod with name Nginx is already existing on the cluster, and if you are validating this with kubectl client, then it will say key, yeah, you can create. But if we validate with the API server, maybe it will reject key, you cannot create, something like that.
So it's something like that. Yeah. So if I
Okay.
say like kubectl run nginx, let's say I have hyphen type is equal to xyz. Okay, it will give this error here. So here in this case, the request is not reaching the API server. Your kubectl, the client tool itself, is validating your request because hyphen type is not a known flag.
All right. Okay.
Okay. Yeah. So now we understood how to create the pod, dry run it, and also get a manifest file out of the imperative way. So I can simply run my pod using kubectl run nginx hyphen image. I can set it to latest. If you want the port, I can also open the port like this. So you will find many more options in the kubectl run hyphen h. Okay. Yeah. So let's try to run it and then exec. So we'll complete. Okay, we will see what all commands we can uh, basically complete for today. So kubectl run nginx, that's the name of the pod. It runs nginx latest. The port that is exposed is 80. So if you want to get the all the objects, okay, if you want to get the objects, you should use kubectl get. Okay, for pods, you can use pods. For deployments, you can use deployments. Okay. So you can go through all these what do you say, available flags and options that you have. Okay, of course, I'll also try to cover most of this. So kubectl get, okay, so you can use the resource names like pods. So pod means here it will give you all the pods information. Okay, so let's say I also want the services related information. Okay, I can use services as well. In this case, it will list all the pods and all the services. Make sure that you separate them through a comma. Okay. So should I use these full names all the time? It's not required. Okay. So if you look at the short names in kubectl API resources, so for every resource, there is a short name given. Like for pod, it is PO. Okay. For services, it is SVC. Okay. So which means if I have to get the resources information, like pods, you can simply use PO. For services, I can simply use SVC like this. Okay. For replica sets, I can use RS. Okay. I can use the short names like this. And always remember, we have something known as namespace. Okay. So if you just look at all the namespaces, NS is the shortcut. Okay. Or else you can use namespaces like this. So currently we have these namespaces. Okay. There are total 5 of them. Okay. So we have a namespace by the name default. Okay. So default is the name of the namespace. It is not the default namespace itself. Okay. Of course, by default, your default namespace is used for deploying or creating any resources. Okay, but still you can also deploy in the other namespaces. You can create new namespaces. Okay. Now, whenever you're running or getting any resources related information like this, you are actually trying to get this information from the default namespace. Okay, so if you want the pods and services from the other namespaces, I need to use -n and specify a namespace. Let's say I want to get all the pods and services from the kube system namespace. Then I have to mention like this. If you see there are more pods and services running. Okay, I want to get information from all the namespaces. Okay, so you have various flags. Like you can use the long flag, that is all namespaces like this. Okay, it will give you information from all the namespaces, but there is a short flag that is -A. So this will also give you the information about pods and services from all the namespaces. Okay, so now my question is, let's say in a default namespace, okay, you are running your application. That application has, let's say, 100 pods. Okay, but only some pods belong to front end. Okay, like 20, 30. So how do I get only those pods? Because if I do kubectl get pod, it will list on all the pods from my default namespace. Okay, but I don't want to see all those 100 pods. I want to see only the front end pods.
We need to specify the namespace.
Namespace, it's the same namespace, default namespace.
Like
The
by
result
using any
will,
label.
Images may be different used there.
You
yeah.
can grab it, right?
So here you'll have a lot of filtering options. Okay. Like you can fetch pods. Uh, uh, let's assume all the front end pods have a common name like FE followed by the name of the pod. So that FE is common. In that case, I can use grep. Let's say I'm just using NG because Nginx has NG. So you can use this grep. So there are other better ways. So whenever I'm creating a pod, okay, it is always good practice to add some labels to the pod. Okay, it is just like adding tags to your AWS resources so that it is easier for you to filter these AWS resources for billing and all, right? Correct? Correct. So whenever you're creating a pod, always make sure that you add some labels, relevant labels. So like, So relevant labels. So where to add the labels and all, I'll again come back to it later. So labels like the name of the app is like front end. So the environment it belongs to is prod. Okay, like team, something like this. So if you add these labels right, it is easy for me to filter them using any of the labels. Like, and filter them through using environment, or filter them with team. Okay, so if I want to see all the resources that belong to the that has the label team set to VC, then I can easily get that entire information here. So this is how you use labels. Okay, you can use them to select uh, various objects running within the Kubernetes cluster. So we'll talk about that again in depth later. Okay. So now, if you do kubectl get pods, you'll get information about all the pods. So currently I have only one. Okay, if you want to get a single pod information, I can actually use like this. I can use the name of the pod like this. Okay, so this is one way. So Kubernetes actually recommends a different way. That is, if you are trying to fetch or targeting a single resource, okay, it is always better to use the type of the resource slash the name of the resource. Okay, so why this is required? Okay, so let me prove it. Okay, so I can run this to get the information about this Nginx pod. Okay, so what if I want to get information about the pod and services like this? Okay, I can get, but this is actually giving me information about all the pods and services. Okay, so what if I need information about a pod called Nginx and a service called Kubernetes, both in the single output? Okay, so then I cannot use something like you know pod Nginx and service Kubernetes. Okay, see here, it is getting confused here. Okay, so it is thinking the pod as Nginx comma SVC, that is one name of the pod, and Kubernetes as another name of the pod. Okay, because there is no clear separation of resources. Okay, actually, what is my intention is, my intention is to get the pod information about the pod called Nginx and information about a service called Kubernetes. Okay, so now it works perfectly. Okay, arguments resource name for may not take more than one slash. Okay, so which means I cannot use I should not use comma. I can use like this. So this way I get information about a pod and the service, specific pod and a specific service. Clear?
Vikram, can you try like without giving the semicolon in earlier case?
Sorry.
Can you try the command without giving comma in earlier case also, like kubectl get pod space nginx space service space Kubernetes? Okay.
Okay. So this is how you get information about a single resource. Okay. So not only that, if I'm trying to fetch information about a single resource called Nginx, so the output that it gives will be a minimal output. As I already said, we have various other output formats like wide, JSON, YAML. Okay. So if I use wide here, what will happen? So I'll get more information about this pod. Okay, so the information like, so what is its IP address, in which node it is running. Okay, so this nominated node readiness gates we'll see later. Okay, so the main information that you are going to get is the IP address of the pod and the node in which it is running.
Vikram, one question. So the restarts status which is shown here, it's referring to pod or container.
Sorry, can you repeat?
So the restart status in the output, it refers to pod restarts or container restarts.
These you're talking about?
Yeah, yes.
That is at the pod level.
Okay, so we apply a restart policy to containers, right? So that how many if it's happening restarts that we cannot see.
That you cannot see it here.
Even the age also refers to the pod only, right? Not the container.
Yeah, age also refers to the pod. Here, one by one, in the sense, here it relates to the container. So you have one container and the all the containers are in the running. So one by one means the total running containers slash the denominator one is the total containers. So all the containers are in the running and ready state.
Okay. If you have two containers, I mean,
It will be like 2 by 2.
2 by 2.
So slowly it will be like first 0 by 2, then 1 by 2, 2 by 2. Like once all containers are in ready state, it becomes 2 by 2.
But the status becomes running even if one container starts, right?
Yeah, correct.
Okay. And the status will not go to succeeded, right? That is referring to jobs, right? Succeeded is not a normal status for pods, right?
Yeah, correct. Now you can also do that. I'll show you again. Okay, it's not required because we have other commands to cover.
Okay.
I'll show all those combinations when we come to that part.
Okay.
Okay, when we talk about commands and arguments, I'll show. Okay, so this is getting the output in the JSON format, ideally used when you are creating any automation scripts or creating your own tools and all, because parsing the JSON information is much easier. So you can get the output in the JSON format. And the YAML format is the most important one. Okay, so here it will show you the key values that you have used while creating, but you will also see some of the key values that the Kubernetes automatically injected. Okay, so when we try to create a pod using the definition file, so we never use creation timestamp. It will be automatically injected by your Kubernetes. Okay, like when this is created. Remember, kubectl get pod nginx is getting the information of an existing pod in the YAML output. Okay, and this is also important. See here, when we try to create a pod, we did not include any labels. Okay, but Kubernetes will automatically inject a label called run colon the name of the pod. It will be automatically created. Run colon the name of the pod. Okay, and this is the name of the pod. This is the namespace in which it is running. So did we use any namespace when we are creating? No, that's the reason why the namespace is set as the default one. Okay, again, the resource version, the unique ID and all are automatically injected. And this is the container name, this is the container image, this is the container port. Okay, so we did not say anything about the image pull policy. It is taken as a default one. Okay, I'll talk about what is image pull policy again later. Okay, and then a termination message path, volumes, a DNS. Okay, so these will be automatically injected. Okay, like restart policy, I did not use it, but it is set to be always because that's a default one. Pod priority is 0. The node name. So what is the use of this node name? Who give this information? Okay, so basically the scheduler will decide where this pod should run, then that the node name will be automatically injected here. Then by looking at the node name, you'll understand like in which node this pod is actually running. So apart from that, all that entire information is added by your cluster itself. Okay, we did not add. You also have other field known as status. Okay, so inside the status, you can see the entire conditions, your container status. Okay, your pod phase. Okay, so your pod is currently in the running. Okay, your pod IP address. Okay, the host IP address, that is, if a pod is running in a worker node, you will see the IP of the worker node. Okay, like that. Got it, guys? And you can also see the conditions. Okay, so like initialized, ready, status true, containers ready. So these are the various states, and this is your final state, that is what do you say, the phase. the status of your pod. Okay. Yeah, restart count is 0. Clear, guys? Guys, understood?
Yes, sir.
Okay, so the declarative way, I'll cover it later. Okay, I won't cover it now. In the next session, I'll cover the declarative way, but let's see a few more commands. Okay, so kubectl run is used to create a resource. Kubectl get is to get the information about the resource. You can get the resource information, the wide output, YAML output, JSON output. Okay. So I also have another command known as a describe. This is just like we use inspect command, right? This is just like that. Kubectl describe. A pod. The name of the pod is engine. So we are describing this nginx pod. Okay. So it will also give you the same set of information, but it will only take the most important ones and then it will put here. Okay, like the name of the pod, namespace it is running, the service account it is using, the node and the IP address in which it is running, the start time, the labels it has, status, the IP address that is assigned. Okay, then inside that pods, how many containers are running, what is the image that is running. Okay, the ports that are exposed on the container level, the status of that particular container, the restart count of that particular container. Okay, the environment variables. Okay, and if there is any volume that is mounted, that volume. Okay, so everything will be shown here. Okay, and also there are some certain events. So here, if you are facing any issue with the pod creation, okay, and if you want to know the exact reason, so there are a couple of commands that you can run. So describe is one command, and logs is another command. Okay, so inside the describe, you will see the entire events. Like, so when you create that pod, okay, who scheduled it, you can see the default scheduler scheduled it onto Minikube. Then what happened after scheduling? So kubelet tried to pull the image. Okay. And then kubelet successfully pulled the image. And then kubelet created the container and kubelet started the container. Do you see any issues here? No, right? But if there is any error, you will find it here. And the reason for that error in the describe output. Clear, guys?
Clear.
Okay. So you can also get the events separately using kubectl events. Okay. So this will also give you all the events, but this is for the entire cluster. You can also limit this events only for the namespace called default. Okay. Or any other namespace. Okay. You will see all the events for all the resources. Okay. It's not just limited for only one resource. Okay. So this is events. Okay. I also have logs. Okay. So kubectl logs. Okay. So here logs, basically we take logs for the pods. You can directly mention the name of the pod like this, or you can simply say po/nginx. So this will give you the logs of the pod. Okay, but these are not the live logs. Okay, this is the log that is stored. If you want to see the live log, you can use -f. This is also known as follow-up log. Okay, you can get all this information by running -h. Okay, you can also just print the last few lines of the log. Okay, you can also limit the logs between a timestamp. Okay, got it? -f follow, it will give you the logs, streaming logs. Okay, and you can get the logs, last n lines of the log using -t. or hyphen tail. If you want to enable timestamps, you can also enable timestamps. So let me do one thing. Let me mm, uh, give you show you all the common. Yeah, it is already there anyways. So kubectl logs nginx will give you the logs of nginx. Okay, and if you have multiple containers, okay, so let's say inside this nginx pod, okay, so nginx is the name of the pod, or else you can use like this. So inside this nginx pod, let's say I have 10 containers. I want to get the information about the logs of all the containers. Then I can say hyphen all containers. I can set it to true. Okay. So let's say there are containers that are named as C1, C2, C3, C4 like that. Okay. And I need information about only one container, that is C1. Okay. Then I can simply say hyphen C, that is for the container, and the name of the container, that is C1, something like that. Or else if you're getting confused, let's say I have uh, two containers by the name frontend and DB within the same nginx pod. Okay, I want DB logs. I can simply say hyphen C, select the container DB within this pod. So only those logs will be printed. Okay, so I think that hyphen C should be before the name of the pod. It should be like this. Okay, and also I can get the streaming logs. Okay, hyphen F. And if I want the last n lines of the log, let's say I only need last 5 lines, I can use hyphen tail. I can set it to 5. So this is one thing. And there are other options. Okay, like I want to see the last 1 hour log, then I can use hyphen since 1 hour. Okay. Any other things? Yeah, timestamp. So if you want to see the timestamps in the log, okay, I can set the hyphen timestamp and I can set it to true like this. Okay. So currently we only have nginx pod. We don't have any individual containers in it. So let me just take that container configuration and let's, okay, just see the logs of nginx. See, these are the logs of nginx. Okay, but currently no one is trying to access it. Okay, that's the reason why you're not seeing any follow-up log. But let me see if I can, generate some, what do you say, call that, nginx application. Okay, so let me use a different method. So kubectl get pods, we have nginx. So let me exec into the pod. So I'll cover this command later. Okay, since we are trying, will be closing the session in some time. I won't be concentrating on this command. Okay, so let me just enter the pod to run a command. Okay, but if you're unable to understand this, just don't worry. Okay, so let me go to the other terminal. You can see the log is updated because someone tried to access the application. Okay, if I try to access the application again, so here what I'm doing is what I did is I entered this particular container and then I tried to ping the local host where it is running. Okay, you can see someone tried to access the application. It's the other log. Clear?
So here we logged into the pod, right?
A pod means here we actually logged in into the container, but we did not mention which container we need to enter because there is only one container. So by default, Kubernetes will try to select that existing container.
Okay, so in case of multiple containers, we need to specify the container name and then we can execute.
Yeah, correct. So I'll talk about that in the multi-container pattern. So usually what you need to do is whenever you're executing into the container pod, right? A kubectl exec -it nginx. I can also pass -c followed by name of the container. Then we'll be executing into that particular container.
Okay.
Vikram, the logs which are shown here are not Verilog messages, right? These are application specific logs, right?
Yeah,
Okay, so we
it's a
define.
log of a pod.
Okay,
That's the reason.
okay, so we define which logs to be coming for the container, or like it's only the application logs we should do?
It's application log. It's a nginx container log.
Oh, okay, name of the based on the image. Okay.
Okay, so adding this hyphen timestamp equal to true will add this extra information. Otherwise, so only these are the log lines. Okay. So that is about, you need to practice these commands like run, get, describe, log. Okay. So let me also cover this exec part. Okay. Then we will end the session for the day. So let's say if you have multiple containers in a pod, okay, if you want to exec into the pod for debugging or for running some extra commands, okay, just like we do Docker exec, you can also do kubectl exec, okay. So kubectl exec, okay, that is exec. You also need to use interactive terminal mode, that is -it, just like Docker exec. So we already know why, okay. So like hyphen is for the interactive input and T is for the pseudo terminal access. And you need to give the name of the pod. Okay. So in case if you have multiple containers in a pod, you need to properly select the name of the pod, okay, to exec into. Otherwise, the default, if a pod has only one container, so it will be executing into that particular container only. Okay. And this is about, just running an additional command. So we say that we are SSHing into the pod or executing into the pod. It's not like that. So whenever we do kubectl exec, we are actually executing extra commands within that particular container. Okay. And the difference between Docker exec and kubectl exec is that, okay, so if I have to exec into a container, okay, by the name nginx and run some command, so I ideally run that command like this, like host name or bash or sh like that. Okay, in kubectl also you have to do the same thing, but you need to use double hyphen and followed by what do you say, the actual command that you wanted to execute. So this is actually the command, and this is the this is the kubectl exec command, and this is the command that you wanted to run within that particular container. In order to separate both, you have to use double hyphen. Okay, that is the only difference. Okay, so I'll just do kubectl. Okay, kubectl exec -it, that's the name of the pod. And I'm going to run sh as the command to get shell access. Okay, I can also use bash, or let's say I wanted to use just the host name. I want to know the host name. Okay, I can run it like this. Or else let's say I want to run a command known as curl localhost within that nginx pod. I can do that. Okay, if you want the shell access, you can just do bash, then you will be immediately logging into the container. Okay, just like how we exec into the container using Docker exec, it's also the same thing, but syntax wise you need to separate these two commands using double hyphen. Clear, guys?
Vikram, when we executing in this container, it shows user as a root user.
Hmm.
So how to control this? Like within pod definition, do you have any option to define the user for the container like that?
Yeah, you have. So if you look at something known as security context in Kubernetes, It's a security related concept which I won't be talking about now. Okay. There is something known as run as. Oh, so this is for Windows. Just a second. Configure run as. It is like run as user. There will be some this thing. Run as user followed by the name of the user. It will come under security context. So let me.
It's on the top actually.
This is for the Windows. Like this. Security context run as user. You can give the user ID. Okay. So if you put it at the pod level, then all the containers should use it. You can also move the security context at the container level. In that case, only container, basically use it.
All right, Vikram. Thanks.
Okay.